All right, welcome to chapter 6. And this chapter we're going to be studying radicals, radicals and roots, and also some fraction exponents coming later in the chapter. It's pretty new probably, but just a couple of little vocab. A radical or a root is mostly you've seen like square root. So like when you do the square root of 25, that's an example of a radical or a root. Right? It is a root, and then this little symbol, the check mark is called the radical symbol. And we're going to start to learn that you can also do third roots. So um, this is square roots, meaning it's like a 2 root, but you can also do like a cube root. And that's one of the things we're going to learn in this chapter, and actually probably in this lesson. So there'll be two parts today. We're going to evaluate these radicals, these check marks, which you already know how to do with square roots, but we're going to extend it to like third and fourth roots. And then we're going to start to simplify. So this is actually going to be in 6.2 is going to be about simplifying, but we're going to start it today in 6.1. And this is probably the hardest part of this chapter, one of the harder things we learn all year, but we'll start with the basics of it today in this video. Okay, so just some radical vocabulary. This whole thing's called a radical, right? The little check mark's the radical symbol. And then the number underneath there is called a radicand. And then an index is just a little number. So just like you kind of have exponents, we like have x squared and x cubed and stuff, you can also have different indexes for roots. So if nothing is written there, it's actually considered a 2. So you might want to make a little note. I would draw this stuff out here and then also put like 2 if nothing is written. Basically, it's a square root, which is a little weird because, right, if you have x and nothing is written, it's to the first power. But for radicals, it's a 2. And then, you might have other third roots, fourth roots, etc., etc. So that little thing right here is called the index. Right, so hopefully you've got this image down. And then maybe a note that if nothing's written there, it's a 2. Okay, so our first goal is to evaluate them. And you already know how to do it. Like square root of 36, you can certainly type it on your calculator, or you're basically thinking what number times itself gives us 36. And the answer to that should be actually both plus and minus 6, right? Because negative 6 times negative 6 is also 36. All right, so a third root then, just ask number times itself one more time. That gives us 27, right? So hopefully we can figure out there, like positive, if you want to think about it a little more, but hopefully you can figure out that that's 3. And we could say, well, is it going to be like over here? Is negative 3 going to work? And it looks like no, that would be negative 27, right? Because these would pair up, but then you'd have one extra negative. So this one is just 3. So here's a good chance for you to think, this fourth root is going to have one or two answers based on kind of the patterns we're seeing up here. And it's number times number times number times number. That gives us 16. All right, so pause the video and think about it. Okay, so certainly 2 is going to work. We multiply 2 times 2 times 2 times 2, that's 16. And then also negative 2 will work here, right? And the reason is these pair up and cancel, and then these pair up and cancel. So if we have an even number there, it cancels out and gives us positive 16. So this one is 2 answers. And so we want to generalize, when do you have like one answer, when do you have 2 answers, and then there's actually cases where you have no answers. So I'm going to let you think about that before going to the next slide. Okay, so in your notes, I would definitely draw this, right? So there's sort of 4 scenarios. You can have an even root. So if you want to draw a couple examples here, that would be the square root, or a fourth root, or a sixth root, right? If that index is even, not the number underneath, not the radicand, but the little index, is that even or odd? So an odd root would be like a third root or a fifth root. Okay, so if the index is odd, I guess I could put this as the index. Okay, and then the other factor is if the number underneath the check mark, called the radicand again, is positive or negative. All right, and so if it is even and positive, you have two solutions. Okay, so this particular one would be plus or minus 4. All right, and if it's negative, there's actually no solution. We talked about in previous chapters that that's actually an imaginary. This is like plus or minus 4i. But in this chapter, we're only going to do a real solution. So maybe we should put no real solutions here, right? And for this chapter, we're not going to do the imaginary stuff. We're just going to do the real ones. So we'll put no real solutions for a negative, right? Because there's no number times itself. That'll give us negative 16. 4 doesn't work. Neither does negative 4. So there's no real solutions to that. And then the odd ones always have one solution. All right, so if you want to just note that these are both one solution, whether or not the radicand is even or odd. In this case, it's just 3. 3 times 3 times 3 gives us 27. And if you have a negative number underneath the radicand, that's okay as long as your index is odd. So here again, if we think about it, to get negative 27, negative 3 times negative 3 times negative 3, that certainly will give us negative 27 because the first two cancel out and then we have one extra negative. Okay, so the main thing here is to know an odd one will always have one, whether the radicand is positive or negative. Okay, so just to put that in practice, here's a couple, and use that little chart, right? The figure out is it even or odd index, and then is it positive or negative radicand? All right, so this is an odd example, and it's negative. Right, so odd negative is going to be one answer, and in this case, it's just negative 2. Negative 2 times negative 2 equals times negative 2 is negative 8. So we got just one answer there. This one is even and negative, so that's actually going to be no solution. Next up, I just want to show you can use your calculator to help on this. So if you have a graphing calculator, I'll pull it out here. You can do square roots right here. It's above this x squared. So I hit second, and then this little square root, so like 25. The only trick is you have to remember that, again, that actually is both plus and minus 5. That one is an even index with a positive number, so it won't tell you both answers. You have to remember that using the chart. If you want to do an index besides 2, usually you put the index first. So I want to do 4, and then I'm going to do math right here. And then this is the x root. They have a button for the third roots, but I just use the x root all the time. So I'm going to hit 5 to get my x root, and then I'm going to do the one we just did was negative 1, and this should tell us that there's no real answers, right? So non-real answers. So that's kind of useful to know, actually, in a way. All right, we get a little error there. Maybe I'll do 1/3 root as an example. So let's do 3 math, and then number 5. So I hit 5 for x root, and then just type a number, say 81. And that one's a crazy decimal, but there's our third root of 81. Okay, so you can use your calculator to help, but again, it won't tell you, the number of solutions necessarily, right? It'll work fine for like third roots because they always have one. And then for these ones, it'll actually tell us that there's no real solutions. But I guess for this one, you have to remember that there's 2 for a positive even. Just a different way of asking it. So some of these are in the homework, so I thought I'd throw up a slide. Sorry, the wrong thing. Throw up a slide. So it's just saying a 5th root of 32. So this one, if you can't do it mentally, might be a good one to do on the calculator to practice. So if you want to write it like this, but that's all it's asking, a 5th root of 32. Pause the video, give these a shot. Okay, for the first one, it's 2. 2 times itself 4 more times is 32, so that's good. 5th root of negative 1, right? Remember, these always have one answer. So again, you could use your calculator here if you need, but it should be negative 1. and then a square root of 100th. Kind of an interesting one. The number actually gets bigger. It's actually 1/10. 1/10 times 1/10 is 1/100th. And don't forget here, this should be plus and minus, right? It's even index and a positive number, so it should be two answers there. Same thing with the last one. This one will have a plus minus answer at the end here. Plus minus. And interestingly, if there's a fraction like this, you can actually like break it into two parts. Actually, let's not do that. Let's just think like we've done before with the square roots. So the way I always think of it is, so here we have a fraction times a fraction that we want to get 36 over 121. So hopefully we can figure out like what we need for the numerator is just 6 times 6. What we need for the denominator is 11 times 11. All right, so that means that we get plus and minus 6/11 as our answer here. All right, fraction times fraction. And so because it's even and positive, we get two answers. Okay. I'm not going to spend a lot of time here because I'm running out of time in my video here, but this basically, hopefully you realize that you can cancel out a fourth power with a fourth root, right? So that would just give us x on this side, and then we'd have plus or minus 3 because this one's even and positive. So if you have to solve, just like we were doing before. All right, so what I want to get to is this is the next one, next kind of second objective is to simplify radicals. Okay, and there's a pattern here that hopefully you kind of realize. So you could type some of these in your calculator, not this one with x, but if you wanted to pause it and type some of these ones in, you'd see sort of a pattern. Okay, so kind of the idea here is if I square 7, that's 49. And if I take the square root of that, it's both plus or minus 7. But to make it simple, I'm just going to list the 7. Here, if you cube 16, sorry, cube 6, it's 216. And then you cube root that, you get 6. Here, if you do 5 to the 4th, it's like 625. And then you do the fourth root of that, you'll get 5. So kind of the idea is that a third root and a third power cancel out. Same thing here, fourth root and a fourth power cancel out. This gives us the 5. Same thing here, these cancel out. A square root and a square cancel out, giving us 7. So if we have something like the cube root of x cubed, that just cancels out and just gives us x. All right, so we're going to extend this, and if you want to put this one example in your notes here, if we have something like this, right, the way we simplify cube root of x to the 12th is x to the 12th, you can actually split that up into different parts. Maybe I should write it up there higher, but x cubed times x cubed times x cubed. All right, that is the same thing as x to the 12th because you'd add those exponents and you'd have 12. All right, so the deal is if I make all of these third roots, all right, so because this original thing had a third root over it, I'm going to split it into multiple third roots. Okay, and the reason is now they would cancel just like they did up there. Right, so now this third power and third root cancel. That's why I broke them into x cubes. Right, so they cancel out and they leave us with just x times x times x times x, which is x to the 4th. All right, so maybe at this point you could see, do you know the shortcut, right? So we could write this out every time and figure out like why it works, but can you see the shortcut here? Okay, and hopefully you realize the trick is you can just take this index, sorry, this exponent and divide it by the index to get 4. Okay, so here's a couple other examples which we'll close on. Pause the video and give them a shot. All right, so we got an index of 2 here. So the square root of 16 is 4, technically plus or minus. You want to put it there, and then you divide the 8 by 2, so x to the 4th. Here again, this index is just going to divide out those exponents, so it'd be a squared b cubed. And then same thing here, just divide the 8 by 4 and the 12 by 4, so we get x squared and y cubed. Okay, so that's our first step in simplifying is if this index evenly divides the exponent. Later lessons, we're going to hit ones where it doesn't evenly divide, and then it gets a little trickier. right? But that's all we're doing in this lesson for now. So that's it.